Now let's run module 5 base. Okay, you're gonna see these warning signs. It's just the information about where we were in terms of the graphical function. So I'm just close this. Okay, and now let's check out the result. So if you look at the let's say susceptible population, if you click graph, now you're seeing the difference between the module 5 base as opposed to module 4 base. Now in module 5, okay, we have a greater number of susceptible population not contracting the disease. That's because people's behavior adjusted based on the death rate, and now people are not out there making contacts with one another as much. Okay, so if you take a look at the infected asymptomatic population, okay, this is module 5, and then this is module 4. So by adding this feedback loop that goes from death rate all the way to the contacts, okay, we are actually limiting the infection of COVID. Okay. Same thing with infected asymptomatic population. Another thing that I want you to pay attention to is this slight up and down, the oscillatory behavior. Okay, so remember that we were looking for the ways to explain the second wave. Okay, so people adjusting their behaviors based on their perception of the death rate, okay, can actually create this kind of an oscillation because people will reduce the number of contacts when the death rate is high, okay, which will lower the number of infection, and that will lower the death rate, and which will bring back the number of contacts per day, which will increase the incident, right? So there is this oscillatory behavior that is caused by this feedback loop. Okay. Let's see what happened to the recovered population. Okay, like more people have recovered in module 4 than module 5. That's because in module 5 a lot of people are still in the susceptible stock. Okay, if you look at the context between infected and susceptibles, this is what's going on. So in module 4, when people are consistently making 15 contacts per day, no matter what, this is what's going to happen. However, when they are adjusting their contact number based on their observation of the death rate, then we have a very low contact that is taking place between infected and susceptibles. Okay. Now let's check out the death rate. So if you take a look at the death rate in module 5, we have a lower rate of death compared to module 4. Okay. However, it comes back a little bit. You see that slight wave. It's a little hard to see, but what's going on here is as people are observing a rising death rate, they reduce their contacts, and therefore there are less people infected with COVID, so the death rate will go down. But when the death rate goes down, people perceive it to be less serious, start going back out and making contacts with other people, which will increase the infection and increase the death rate, right? And then when that happens, people will reduce the number of contacts, and then the death rate will fall. So we're going to see this slight oscillatory behavior in the system. Okay. The cool thing about simulation model is we can change different variables value and see what that does to the simulation result. Okay. So what I can do is you can go to sim setup, and all the variables that we can change the value of will light up in light blue. Okay, so what I'm gonna do is let's see what's gonna happen if the time to perceive changes in death rate is not 21 days, but it's way shorter. Okay, like 5 days. Okay, so we change it to 5, and we're going to change the simulation result file name. I'm going to say 5 days to perceive change. Okay, so now we ran the model with 5 days to perceive changes in death rate, and let's say what that does to the incident rate. So if you click incident rate and click graph, okay, this is what's going on. So when we make people to perceive the changes in death rate at a much faster time frame, then we can actually reduce the incident rate much quicker. So other than this is the module 5 base, okay, with 21 days, and this is 5 days. So we are cutting the time delay, and the system responds to the death rate much faster, and then it's gonna reduce the overall incidence rate. Okay. We can change other things too. So for example, go to sim setup, and then if you go back to time to perceive the changes in death rate, it's still gonna be 21. We changed it to 5 for the previous simulation run. Okay, so it's just gonna maintain its default value. Okay, but this time, let's say that you want to change this graphical function. You think people are too sensitive to the death rate. Okay, so if you open this, what you can do is you can actually grab these coordinates and move it around. So let's say that people are gonna be less sensitive to changes in death rate. Okay, as such. All right, now click OK, and then let's say this is less responsive to death rate, and I'm gonna simulate it. And now you can go and click incidence rate and take a look at it. And the green one is the module base. Okay, and now when we make people less responsive to the death rate, now you're seeing the people are experiencing way higher incident rate because people are not adjusting their number of contacts based on changes in the death rate. Okay, so let's take a look at the number of contacts per day. Yes, from let's see, the base is a green one. People start from 15 contacts per day, but they quickly reduce it to like less than 1 contact per day in a base run. But in less responsive scenario, people don't really adjust their behavior that drastically, and that's where the 21 days to respond to the death rate. So these are kind of scenario tests that you can do. You can go to sim setup and change out different numbers and see what that does to the simulation result. Okay.